Today, block block two, unit three, we will discuss block two, unit three. In that, the chapter is photoelectric effect and matter waves. In photoelectric effect, we will see the what is the introduction of photoelectric effect and how Einstein is explained this photoelectric effect. Next, we will come to the counter effect and dual nature of the light. What is the concept of matter wave? Today, we will see this topic where with the two or three problems. First, we will see what are the objectives we will learn from this chapter. First, we will see the photoelectric effect. What is photoelectric effect? What is quantum effect? How it nature on the basis of quantum theory. What is the nature of this one on the basis of quantum theory? We will see, and we will calculate the threshold frequency and work function. When the light falling on the metal, when the metal emitting the photoelectrons, and we will see the different velocities in the matter waves. Then we will see the relationship between the different types of velocities in the matter waves. Then we will go for the Heisenberg uncertainty principle and what are its consequences. First, we will see the de Broglie wavelength. Light, when the light we will refer using the term called photons. This light photons is explained on the basis of Planck's theory. With Planck's ideas, we will discuss this one few. Newton proposed the hypothesis of light, but the facts which were supported were found afterwards. It is explained by Fresnel's based on the wave theory of light, which it is proposed by the Huygens. Here we are using the de Broglie wavelength. Before discussing de Broglie wavelength, we will discuss few terms called lambda. The first term is lambda. What is the lambda? Lambda is the wavelength of the light or wavelength of the moving particle. And nu is the frequency, v is the velocity, h is the Planck's constant, E is the energy. Based on the terms, I am writing here phase velocity. Phase velocity is represented with nu lambda, where nu represents frequency and lambda represents wavelength. Nu represents frequency and lambda represents wavelength. As we know, Einstein equation E equal to mc square. This one, where c is the velocity of light. Using this one, I'm combining the two equations. E equal to mc square and one more we have E equal to h nu. E equal to h nu. From this, I'm writing nu equal to E by h. But what is the formula of E? E equal to, we have formula mc square. And substituting in that one, we are getting nu equal to mc square by h. This new value, I'm substituting in first equation, equation number 1. What is equation number 1? This is equation number 1. W equal to 2. Nu lambda is equal to equation number 1. W equal to nu times of lambda. Nu times of lambda. In place of W, substitute mc square by h. In place of lambda, substitute another one. Lambda equal to hmv. We have two parameters. As per de Broglie equation, what is lambda? Lambda equal to h by mv. Substitute nu and lambda both in phase velocity. Both in phase velocity. Then we can write W equal to 2. What is nu? mc square by h into h by mv. HH will cancel, mm will cancel. So phase velocity I am getting W equal to c square by v. The formula of W. Phase velocity is calculated. Phase velocity, what we got here in this. This new This H is cancelled. Mm is cancelled. So finally getting W equal to C square by V. This is the phase velocity formula. Here we have two conclusions. What are the conclusion? Wave velocity and particle velocity, both are different. Two types of velocities we are concentrating here. One which we are concentrating is wave velocity. Another one which we are concentrating is phase velocity. This wave velocity and phase velocity, these two are different. Particle velocity is less than c, whereas wave velocity is greater than c. Here we have two velocities. One is particle velocity, another one is wave velocity. Here wave velocity is greater than c, particle velocity is less than c, wave velocity is greater than c. To avoid confusion, what we are finally giving conclusion that. So from this, we discussed wave velocity as well as phase velocity. What is the relation between wave velocity and phase velocity? Means what is the answer? Wave velocity, phase velocity W equal to C square by lambda. So this is the equation of wave velocity and phase velocity equation. So what is this topic we discussed? Just we saw the introduction part. Introduction part using de Broglie wavelength. Next topic is photoelectric effect. Next one, we will see the photoelectric effect. What is this photoelectric effect? Emission of electrons by metal surface. Suppose here I have a metal surface. I am passing light. I am passing light to this metal surface. What is this one? This is metal surface. This whatever the rays I am using, that is UV rays. When UV rays is falls on the metal, it emits some electrons. What is output? Electron. Here, metal, to this metal, some radiation is falling on this metal. It emits electrons. So this is called as photoelectric effect. Here what is mentioned? Emission of electrons. From where it is emitting? Emission of electrons from metal surface. When it is emitting electrons? When bombarded by light. When light is falling on the metal surface. This is called as photoelectric effect. This photoelectric effect is discovered by Henry Hertz in the year 1887. See here, we have diagram, photoelectric effect diagram. In this photoelectric diagram, this side, I am using UV rays. All these rays, whatever is the rays is there, these are UV rays. This UV rays is falling on to, here I have two electrodes. This one, photocathode electrode. Photocathode. What is PC here in this diagram? PC is photocathode. S is second electrode. S is second electrode. So we have two. These two is attached to the voltmeter. Again, I am drawing diagram here. I am taking one metal surface. In this first electrode here, whatever the first electrode is, this is one is photocathode PC. Full form of PC is photocathode. Under one, I have second electrode. This second electrode is in terms of positively charged. This is acts as a positively charge. This acts as a negatively charge. To this one, I am sending UV rays. To this one, I am sending UV rays. If the rays are falling, light is falling, it will penetrate inside and falling on which? Photocathode. From UV rays is passing to the second S. S means secondary. PC means photocathode. This is the first one. As the rays is coming from outer side, it is penetrating inside and falling in the first side. At that time, the electrons is emitted. Outside, what happening here? Electrons is emitted. Whatever the electrons is emitted, We are calling that one as the emission of electrons is called as a photo effect. Now we will see the diagram. A description of this diagram. What is given? A glass tube. See here, a glass tube contains a polished metallic electrode called photocathode. And second electrode we have that is called as a metal plate. These two are maintain a potential difference of some volts. So there is some voltage differences between these two because we are connected one terminal to negative, another terminal to positive. As this is secondary is connected to positive, it acts as a positive. This negative is connected to photocathode. This is acts as a negative. When the ultraviolet rays are falling through the secondary electrode, what happens? It is incidenting on the inner surface of the photocathode and some current is flowing through the tube because electrons is emitting, some current is flowing. This phenomena is called as photoelectric effect. In this, very low pressure is acting when the current carried is not a gaseousness. Next. Experiment is carried out here applying magnetic field to the region between the photocathode and secondary electrode. What it means, this photocathode and secondary electrode. In between these two, I'm applying what magnetic field. At the time, what happens? It flows a negatively charged particles. So Thomson discovered the existence of electrons such that negatively charged particles of the photoelectric could be electrons. So here what happening? After applying the magnetic field, here this one is photocathode, this one is secondary electrode. By applying magnetic field, we are observing some negatively charged particles. This negatively charged particles is treating as what? Electrons. So this is observed by Thomson. Thomson discovered the existence of electrons and he checked the negatively charged particles of the photoelectric field could be the electrons. Next, we will see what are the observations we are observing from this experiment. We are observing some minimum energy. Some minimum energy is observed. That minimum energy is called H nu naught is some minimum energy. Some minimum energy is observed. That minimum energy is called H nu naught. And kinetic energy here I am taking as a K maximum. Here, kinetic energy, K maximum is directly proportional to the whatever the light is falling on the material. But kinetic energy is directly proportional to whatever the light it is falling. But work function is here, work function is called as W. The work function of the material is independent on the light. Here we are discussing two factors. What are the two factors we are discussing? Here we have two factors. But we have one kinetic energy. Under function, we have work function. Here, kinetic energy is directly proportional to the light. Whereas work function is independent of light. These two things we have to concentrate. And also we have to concentrate on the initial, some minimum photon energy. Initial photon energy is H nu naught. The initial photon energy, whatever we are taking is H nu naught. Whatever the initial energy we are taking, some minimum energy is there. That minimum energy is called H nu naught. For a given material, there is some minimum photon energy H nu naught, which is the characteristics of the material. No photons are released less than nu naught. No photon, so minimum energy is required to release the photons. That minimum energy is greater than nu naught. If it is less than nu naught, no energy is released. That energy, that H nu naught is called as threshold frequency. And K maximum here is from this, the important questions maybe we can expect from the important questions is one is a photoelectric effect, another one is a Compton effect. We can expect questions. Mm. Some minimum energy we are taking. So third point, what we have, whatever the current is producing is directly proportional to the light intensity. Whatever the current it is producing is inversely or directly proportional to the light intensity. And there is no time lag, means no wastage of time between the radiation and emission. What is the meaning of radiation and emission? Whatever the light is falling across the secondary, here we have one secondary, another one we have photocathode. Whatever the light is falling on the secondary is called as a radiation. Whatever is coming outside, that is called as a emission. So there is a no wastage of time between radiation and emission. But there is no wastage of time between radiation and emission. Hmm. This is one point. So what are the points we discussed in this? First point is we have some minimum threshold frequency H nu naught, and kinetic energy is directly proportional to light. Mm. Work function is independent. Work function is independent of light, but kinetic energy is directly proportional to the light. Next, what we discussed. Next, current is directly proportional to the light, and there is no time lag between input and output of the emission. So this is photoelectric effect. In this photoelectric effect and Compton effect, both are important questions from this chapter. So what is the question is given here? The photoelectric is directly proportional to what is the answer? Directly proportional to the light intensity. What is directly proportional to what? Light intensity. Photoelectrons will be released if the frequency of the incident radiation, whatever it is, incident radiation is greater ఉండాలా lesser ఉండాలా? Greater symbol, greater than threshold frequency. Threshold frequency greater than ఉన్నప్పుడే electrons is releasing. Next we will see photoelectric effect. How this photoelectric effect is explained by Einstein. Just previous we saw only the definition of photoelectric effect. Now we will see how this photoelectric effect is explained by Einstein. Here, different using Planck's constant or Max Planck's, this Max Planck's, which it is explained in 1905, this photoelectric effect based on the quantum theory using black body radiation. Here we are taking different radiation sources. First radiation source is 0. Next radiation source I am taking H nu. Next source is 2H nu. Next source is 3H nu. Like the different radiations I am taking n times of H nu. The last energy state it is H nu. Before that one is n minus 1 times of H nu, where c is the velocity of light, nu is the frequency, h is the Planck's constant. And this energy, the bundle of energies of this one is called as quantum energy. Whatever the energy bundle we are referring, that energy is called quantum energy. And we have energy equation formula E equal to H nu. What is energy formula? E equal to H nu. Now here what we are discussing, as in general, from valency band to conduction band, in between we have Fermi energy level, EF. Whatever we bottom side I am representing with valency band, the upper one is represented with conduction band. This is what? This is conduction. But light energy in terms of photon falls, what happens? It will get some sufficient energy and moves towards the conduction band, from where it is moving from valency band to conduction band. At that time, some energy is released outside. At that time, some energy is released. So here we are using one term. So in this diagram, H nu is the frequency, equal to Fermi energy level. This is your Fermi energy level. This is valency band. This is conduction band. And so after passing some light energy, it is losing some in. So total how this diagram represents in general. Here we have conduction band. This side we have valency band. When light falls on a material, from where to where it is going? It is going from valency band to conduction band. Is the middle of the part I am taking as a Fermi energy level, EF. Again in the up, this space is divided into two. One part is divided is called as work function W. Here K kinetic energy, another half part is called as work function W. So this one we have upper part is kinetic energy, down part is work done W. This is the explanation of the diagram. Next will come the next one. We will see here the photoelectric emission is taking place. When this photoelectric effect is taking place, the photoelectric effect is taking place when energy is greater than Fermi energy level plus work done, where EF is the Fermi energy level state. What is EF? EF is the Fermi energy level. Now we will see the energy that is across the inside is EI. And now next total kinetic energy I am writing. What is total kinetic energy form? Energy when it is incidented H nu minus EF plus work done. From this, initial energy is treated as Fermi energy plus H nu minus EF plus work done. EF will cancel. So what you got? H nu minus W is equal to here kinetic energy of mv square. So H nu equal to of mv square plus W. This is the formula of photoelectric effect. Very, very important question. So this is called what? Einstein photoelectric effect. You will get problems based on this formula. So what is photoelectric effect formula? Using who derived this equation? First, 3.2 photoelectric effect, which is the page number 39, is about the description of the diagram. What factors it is depending. Next, photoelectric effect and Einstein explanation, which is 3.3. Here we saw the derivation of the photoelectric effect. And what is the final formula? Final formula equal to H nu naught plus of mv square. Or we can also call H nu equal to work done by the body of mv square. This H nu. This is the formula of photoelectric effect. So this explanation is done by who? Photoelectric effect by Einstein explanation. Based on this, we have it is depending on which factors we have here. See here, what is the formula? Here, what is the formula? H nu equal to not H nu is equals to H nu naught plus m square. Now I am drawing graph across LHS new frequency versus RHS kinetic energy of mv square. This is kinetic energy. These two are directly proportional. What is the meaning? As the frequency is increasing, kinetic energy is different for different values. As frequency is increasing, kinetic energy is also increasing. Next, on what factors it is depends upon. By here we have to write 4 factors, steps we have to write. This photoelectric effect is from the equation 3.4. What is equation 3.4 here? From equation 3.4. What is equation 3.4? K max Equation 3.4 is K maximum equal to H nu plus W. Here, what you understood of mv square is velocity is directly proportional to the frequency. Here, this is velocity, this is frequency, nu naught. Velocity is directly proportional to the frequency. It is given in the first point. See here, velocity of the photoelectron is directly proportional to the frequency of the radiation. Next, see here, velocity of the photoelectron at half mv square. Velocity of the photoelectron is independent of the intensity of light radiation. So it is not radiation. Next, there exists a threshold frequency. What is threshold frequency? Suppose I'm increasing frequency. Here frequency is what the X-rays are falling on a wood block. Graphite block. Which block we are using? We are using graphite. Compton experiment is this figure is are falling from the X-ray. It is on the graphite block. After falling a graphite block, or it will scatter in this direction, or it is scattering in this direction, or it's scattering even backward direction also, it will scatter. So when it is scattering in different directions, it's producing some angle. That angle is scattered angle. Here, what is T? T is radiation. After reflecting on a Bragg spectrometer, those rays is called secondary. Primary line, secondary line. With the what is this one? With an angle theta. With what spectrometer we have? Here we have Bragg spectrometer. The next, across different wavelengths we are seeing. Suppose if it without scattering, it is coming at that time. Okay. With small like this, it is going with angle of 40, with angle of 90, or with the angle of in backward direction, it is reflecting back the 30. At the initially, it is see this one like this is for theta for 45. Initially, with some angle, lambda Derivation, that's it. See equation 3.4. We don't have LHS term. LHS term is 0. 0 is equals to 2. H nu naught by C times of sine theta plus M naught B I am taking as a MV sine phi. Where this one equation is written, this equation is written here. Where this second equation. This second equation is same as this equation. This second equation is same as equation 2. See, check, cross check here. This second equation number 2 is same as M naught B. In place of M naught B, I kept M. In place of M naught B, I kept M. Now, we will see first equation. What is the first equation we have? H nu naught by C, 3.13. This is vertical direction is over. Equation 1 is in terms of sine. And what is equation? This is printing mistake. Actually, equation 1, what we got? H nu naught by C cos theta plus H nu naught. Equation now we are seeing 3.13. Nu naught by C is equals to H nu naught by C cos theta plus M naught we are taking as a M K M K cos phi. So this is here correction. ఇందులో మిస్టేక్ ఉందమ్మా ఈక్వేషన్ లో చూడండి ఇది 3.13 నుంచి రాస్తున్నాము హెచ్ న్యూ టీటా బై సి యాజ్ ఇట్ ఈస్ ఉంది కాస్ టీటా ఉంది ఎం నాట్ కే ని దిస్ ఇస్ వి ఎం నాట్ కే ని ఎం రాసాము కాస్ ఫై రాసాము కాస్ ఫై రాసాము దీనికి మనకి ఎల్హెచ్ఎస్ కూడా ఉంది ఎల్హెచ్ఎస్ ఏంటి హెచ్ న్యూ నాట్ by C. So finally, I am expressing many corrections in this. Many corrections I will write on the whiteboard. Just copy this one. There are some mistakes in the test book. Two equations I will write. Just cross check those two equations. What are the two equations we have? First, we will see the equation in horizontal direction, the equation in vertical direction. The equation in horizontal direction is what we have H nu naught by C equal to H nu theta by C times of cos theta plus M naught KB cos phi. What this is the equation for what we have? This is equation for horizontal. Next, come for the equation in vertical direction. The next equation is in vertical direction. What we have equation in vertical direction? H nu theta C means no LHS part. LHS part equal to 0. C times of sine theta plus M naught KB sine phi. This M naught K I am taking as a M. So what you will get is nu naught by C times of sine theta plus m times of V times of sine phi. In the textbook, this is represented as equation number 2. In the textbook. In the textbook, it is represented as equation number 2. Then what is equation number 1 is taken? Equation number 1 is same first equation, whatever we have, h nu naught by c equal to h nu theta by c times of cos theta plus m naught k I'm taking as a mv cos phi. This is equation number 1. This is equation number 2. Equation output. So next what we have to do? Taking two equations, taking equation 1 and 2. Taking equation 1 and 2. We will see this one in the next tomorrow class. Further simplification. Till one page derivation part is there. Just we will see this one. Continuation is a lengthy derivation. We will see that tomorrow class. So today up to where we completed deriving up to vertical derivation and horizontal derivation. Again, a little bit introduction I will give what we discussed today. What we discussed today. First, we saw what is de Broglie wavelength based on just recap of today class. Phase velocity is calculated. What I got phase velocity I got W square equal to C square by V. W equal to C square by V is the velocity of light. Phase velocity of the particle we discussed. This is the one topic we discussed. Next, we discussed photoelectric effect. In photoelectric effect, there is a metal. One side is photocathode we have. Another side secondary is there. Some voltage is in between this one. And a UV rays is falling on this secondary, which it is entering into this one. When it is entering into this one, some electrons are emitting. So for this one, what we have formula? H nu naught, H nu equal to H nu naught plus of mv square. Some kinetic energy is produced. This is called as threshold frequency or work function. H nu equal to W plus of mv square. This is derived by whom? This is derived by Einstein. The first two topics is there based on this. First topic is circuit diagram explanation, what factors it is depending on, what factors it is not depending. Next, the third topic we will discuss is Compton effect. In Compton effect, what we have? A metal surface. When electrons is falling on the metal surface, when electrons is falls on the metal surface, it's scattering in different angles. Phase scattering angle will change. If it is in a straight, it is theta equal 0. This is theta 35. This side, theta 90, theta 135. Like in any direction, it will scatter. First, we calculated momentum. Again, we will calculated equation for horizontal. Next, we calculated equation for vertical direction. Equation for horizontal direction. Next, equation for vertical direction. Still further is there in this. We will see that tomorrow class.